I would like to talk about some common climate change misconceptions that I have noticed over the few years that I've been teaching this course. So one is that climate and weather are the same thing. And we have to remember that weather would be an individual event on a particular day. So we could talk about the precipitation, we could talk about the temperature, but weather is over a pattern over a long period of time. So like many years. So like maybe the last 20 years, the last 50 years. And so we see that climate needs to be taken into consideration in the long-term patterns. So climate is different than weather. So a misconception is climate is the same thing as weather. Okay. Another misconception is that when we have events like extreme weather, like extreme cold, that is evidence that climate change is not happening. Global warming is not happening. So extreme cold events are a sign that global warming is not occurring. So you'll notice that we talk about climate change because in some places we might predict that the changes in the atmosphere and ocean circulations might actually cause a decrease in temperature. So when we talk about the Arctic, which is heating up faster disproportionately compared to the rest of the planet, we could talk about the flow of the atmosphere and the polar vortex that sometimes comes down from the Arctic during the winter and makes the winters in, say, for example, North America, in the United States, the Midwest, more cold. So we tend to have more extreme weather events. We might also predict that if the global conveyor belt of warm water going up towards Europe slows down, then that is also going to cause extreme cold in Europe. And so this is also shown to be part of this climate change. So we do have, or we might predict that there will be extreme weather events, including cold weather occurring with climate change. Okay. The third thing is that smog or air pollution is greenhouse gases. So smog is the same thing as greenhouse gases. So smog is at the level of the ground, and it can be observed like over big cities as kind of like a brown haze that covers the area. And we know that in China, for example, in Beijing, that smog causes all kinds of health problems in people. So smog could be carbon dioxide. It is carbon dioxide, but it's also nitric oxide and other pollutants that come about from the combustion of fossil fuels. Now, greenhouse gases are not at the level of the ground. So the greenhouse gases are like up really high in our troposphere, which is like 12 miles up. So those greenhouse gases are different than what we would refer to as smog. So if we look at, say, for example, a diagram showing this greenhouse gases, they are way up here in our atmosphere, right up here. And they circulate. So it is a global thing. So if you're releasing CO2 in China, that is going to get up into our atmosphere and it is going to be everywhere in the atmosphere. It's not just going to be right over China, right? So when we look at this, we can see that carbon dioxide and methane and water are also important. So it's not just carbon dioxide that is a greenhouse gas. So water also. As we heat up the planet, sometimes we get warmer temperatures that could cause more water to evaporate, and that would be like a positive feedback mechanism. Okay, So that would be another misconception. We could also talk about the ozone layer. So the ozone layer is also high up in the atmosphere, but it is different than greenhouse gases, a different issue. So when we talk about the ozone, so this would be number 4. Climate change, the misconception is that climate change and ozone layer depletion are the same issue. This is not true. This is a misconception. So a lot of people get confused. So we do produce some greenhouse gases, the chlorofluorocarbons, or CFCs. So CFCs are a type of greenhouse gas, but they also interact with the ozone and actually cause it to break down. So what do we need the ozone layer for? The ozone layer is a good thing because we need it to protect us from sunlight, UV radiation. So as UV radiation comes into the planet, it can be absorbed by the ozone layer, the ozone shield, right? And it can actually prevent certain amounts of UV getting through and getting into our skin and causing genetic mutations. So as we deplete the ozone layer and we create ozone or holes in the ozone shield, then that tends to be associated with increasing rates of cancer, for example, in humans. We have actually solved this problem. It is a success story because we gathered momentum. When I was a kid, you stopped using aerosols. You did not use your hairspray, right? And you went to like pumps, right? And so that actually decreased the release of CFCs into the environment. We also have these in refrigerants. And so it's important that your air conditioning, for example, in your car doesn't leak the chlorofluorocarbons, right? And it's also, they're actually fixing that problem by creating new refrigerants so that we can have air conditioning without having this risk of releasing these chlorofluorocarbons into the atmosphere. So that is another misconception, is that climate change and ozone layer depletion are the same issues, just like smog and greenhouse gases are the same issues. That is not true either. So if we look at the sun, it's also not true that our sun is actually becoming more intense. The same amount of solar radiation is hitting the planet. It's just that the greenhouse gases are preventing that energy from being re-emitted, so from being reflected out to the outside. So if we look at some examples of greenhouse gases, notice that we have CFCs. One of the problems with these is that they, like carbon dioxide, have a long atmospheric lifetime. Look at this, 120 years it takes for it to be removed from the atmosphere. So when we look at these greenhouse gases and you look at the most the ones that are pushing our increase in global temperatures the most, it would be carbon dioxide. So carbon dioxide is the the type of greenhouse gas that is causing the most changes in our overall climate system.